Let's look at our scenario. Okay, remember that when doing your design brief, okay, you should know what a design brief is because we did do it in term 1 already. This scenario here is very important for you to understand. Okay, you'll get most of your information here. Remember that in the design brief you are going to be explaining the problem and the solution. Okay, so let's go through it. A kettle uses electricity at a rate 30 times higher than a normal light bulb. A lot of electricity can be saved if the kettle is used more effectively, right? It uses a lot of current, okay? So it uses a lot of resources as well. So by saving the electricity, right, this will be good for the environment, okay? And it will save resources. If a kettle keeps boiling without being switched off, it uses electricity unnecessarily, because remember, most kettles switch off when the temperature of the water reaches 100 degrees Celsius. Now you don't use it at 100 degrees Celsius, okay? So usually wait for it to cool down, and that heat escapes into the environment. So it is basically wasted, okay? This leads to a wastage of electricity. If you drink your tea without cold milk, you do not want boiling hot water, which is 100 degrees Celsius, because it will burn you. So it is a waste of electricity and time to bring the water to its boiling point. Most of the time, a kettle only needs to heat water to a temperature of 75 degrees Celsius, because that is the temperature at which you mainly use it. If the kettle keeps heating water to a temperature of 100 degrees Celsius, it is a waste of electricity. Right, so this is basically the problem, right, that we are dealing with. Now you have to think of a way to solve this problem, okay? And here is it. You will design and make an energy saving switch for a kettle, right? So this is what you need to do, an energy saving switch. The switch will be controlled by an electronic circuit so that the kettle will automatically switch off when the water reaches the required temperature. Right? The electronic circuit will have a variable resistor so that the temperature at which the kettle will automatically switch off can be set by the user. So that variable resistor is very important. Okay, this allows you to change to basically set it to a temperature that you want the water to switch, that you want the switch to go off. Right? When the switch is off, current stops and the water will the circuit will basically be switched off. Right, this is the symbol here for a variable resistor. Okay, when designing your circuit, be sure to incorporate this symbol here. Okay, right. Now, if you don't know what a resistor is a device that opposes current. Okay, so it goes against current. So the resistance can increase to such a point where the current will stop flowing. Okay, here's an example of a kettle switch. Now, when doing your design brief, you will state the problem. Do not write it as it is here. Okay, you are going to shorten it. Obviously, put it in your own words. Understand it. When you are done stating the problem, you are going to say, I am going to design an energy saving switch, and finish that sentence. Okay. Basically explaining what it does. Okay, please try and put it in your own words. Okay, you will be allowed to do this on your own, or you can do it with somebody from school. Just see if you would like to join a group. If you don't want to join a group, that's fine. You can also do it by yourself. Okay, right. I've given the learners at school a double sheet of paper to start answering. Okay, you can use that. I will also give you isometric grid paper for doing your isometric drawing, and for your orthographic projection, right? That you can just use a normal plain white sheet of paper. If you remember, we did orthographic projection in the beginning of the year. If not, you can refer to your textbook. If you don't remember, refer to your textbook, or if you don't understand how to do it, message me and I will help you. Okay, you did do isometric drawings last year in grade 8, but if you need a refresher, just message me and I'll explain to you how to do it. Okay, remember, it is a drawing that goes at a 30-degree angle to make it 3D, but I'll explain when we get to it. Okay, so here for the design brief, you are going to say what is the purpose of the switch you will be designing. Okay, remember, go and read the scenario and you can get your answer from there. Please do not copy it, put it in your own words. Think about how easy it is for people to do things, right? The impact on the environment and the costs involved. Okay, so you need to think about these aspects also and put that in your design brief. Okay, it needs to be short, that's why it's called a design brief, right? Okay, then we're going to look at specifications. Now, if you remember from term 1, I explained to you what specifications are. Specifications are the details about the product. Okay, you can use these questions here as a guide and you can add in your own specifications, right? For example, what other components you are going to be using, how big your circuit is going to be, all of that stuff. Right, let's look at some examples of what you can include in your specifications. What parts should the device have where the user must press or turn something by their hand? Okay, so this can be referring to the variable resistor in the circuit. Right? Are there parts of the device that would sometimes be moved by the user and other parts that will be moved automatically? So obviously the variable resistor will be moved by the user to set it, okay, and the switch will be moved automatically to switch it off. Okay, remember, when we put the switch off, this stops current, so the water will stop heating up. How should the moving parts of your switch work? For example, what should cause it to move one way and what should cause it to move the other way? Use names for the different moving parts as well as for the other parts that will make the moving parts move or stop them from moving. Okay, remember that our variable resistor is going to respond to the temperature of the water. So if you set it to go at 75 degrees, that will cause it to, the switch to move and prevent current from flowing through. Okay, what type of electrical component can generate the automatic movement? Device has to perform. This component will be the output device in the control circuit. Okay. Does your device need a container or supporting structure to keep all the parts together? What type of container or structure do you think will work well? Right, now these are all of these specifications are your choice. Okay, you can design it however you would like to. Okay, you can even add on more details if you'd like. Now let's look at our constraints. Our constraints are our limits. Okay, it's things that are going to it's factors that limit us when designing a product. Okay, for example, the things that you will need, you have a time limit, the function that your product must carry out. Okay, so for example, when writing your constraints, you must start with my design must. Okay, so my design must save electricity. You understand? It must switch off at maybe 75 degrees. Okay, for your constraints, you can make a list of the materials that you will need, right? Your circuit components. You're going to make a list of tools that you will need when building your circuit and make a time schedule showing how much time you have to design and make the circuit. Okay.